Welcome back everyone. In the last few lessons we saw the details of bracketing methods, and we promised in our last lesson that from today we are going to look at open methods. But before diving into the open methods, I would like to introduce you to some methods that is used in both bracketing method and open methods. This is incremental search. Although these methods or algorithms are used in bracketing methods and open methods, but that's why I wanted to introduce you to it before discussing the open methods. So let's dive into the details of incremental search and see how these incremental search methods can be used both in bracketing methods and open methods. We have seen in the bracketing methods we need to assume an initial boundary for the method. For example, in bisection method or the false position methods we have seen, we need to define the x lower and the x upper points for the sake of boundary locations, and then we calculate further within those methods. But how do we define these two boundary points, x lower and x upper? Are these arbitrary assumption of every person? No, there are, yes, actually it is. Anyone can assume any point, but based on those initial assumptions, your convergence might be faster or your convergence might be slower. And that's why we need to be a little bit more careful about choosing these two values initially. So graphical method is one approach that we can apply. For example, before applying the bisection or the false position method, we plot the function in a graph, and then we see at which locations the function intersects the x-axis. And based on these observations, we can define our boundary notations. So this is a graphical approach, but there is an alternate approach which is incremental search. The problem of graphical approach is that it requires a human intervention. That means it is not an automatic approach. So to implement the methods in computer codes, we need some automatic functionality to assume our initial boundary points, and that's where our incremental search method comes into play. So what do we do in this method? This method involves searching the function values such successive search points. That means we value the function, we evaluate the function at successive points, and we try to keep the track when the function changes its sign. And whenever we see that the function changing its sign, we take the boundary of these successive search points as our initial assumption. So we will look into the details of this incremental search in the next slide. So let's dive into more details what we mean by successive search points. Let's look at the details of incremental search. This is a sinusoidal function, and if we want to find out the roots of this function, we see that there is a root at near 1.5, near 3.2, or on the vicinity of 4.7. So there are many roots of this sinusoidal function, and if we plot this function before diving into the bracketing methods or open methods, we would have assumed that our initial boundary to be 1 or 2 or 2.5 and 4. So if we take these boundaries 1 and 2, we will be sure that there is a root within these boundaries. But that is not an automatic approach. We need to find a completely automatic approach which can be implemented in our codes. So that's where the incremental search comes into play. So what we do, we evaluate the function at successive points, and these points are equally spaced. So these points are equally spaced, and we calculate the function value at this point. For example, at this first point, it is almost x equal to 0.2. The function value is positive. On the next point, the function value is also positive, and equally spaced in the next point, the function value is also positive. So what we do, we calculate the function value and its sign at successive equally spaced points. For example, at this point, which is 1.2, the function value is point, but at the later point, which is 1.7, the function value is negative. So we can take these boundary points, 1.2 and 1.7, as our initial boundary. So that's how we calculate our boundary values using incremental search. So similarly, if we calculate further, we will see at equally spaced points the function value is at some points negative and at some points it is positive. So that's where the incremental search is used. So look at this, some points have positive value and some points have negative value. And in the first case, in the first notation, in the first case, look at this, at these boundary points, that the function changes its sign, and that's why R1 can be used as a boundary. Similarly, R2 can be used as a boundary. Why? Because at the two vicinity of the boundaries, the function changes its sign. At one point it is positive and at another point it is negative, and that's why R2 can be used as a boundary. Also, R3 can be used as a boundary. So all these boundaries, R1, R2 and R3, can be used as boundary points, and this is an automatic approach which can be applied in our MATLAB course or Python course or whatever. But there are some problems in incremental search. For example, how do we set the equally spaced location? That means, what is the length of the space at which we are going to calculate and evaluate our function? So this is one limitation. If we reduce the length to be very small, it would take a huge amount of computational time and resource. And on the other hand, if we take a large space, that means this space is to be very much larger, then it might happen that we might not find any possible boundary. So there is a trade-off between the computational resource and accuracy that we want to find out. So there should be a trade-off whenever we set the incremental search method and whenever we try to set the incremental step size. Okay, so that is our first limitation. So also this limitation is further compounded or further extended by the possible existence of multiple rules. So this is another limitation of incremental search. Remember, incremental search is a brute force method. It's a very basic method of applying our initial boundary locations. Although it is brute force, but it is the first method that we know until now, an automatic approach of finding out our initial boundary, and that is much better than the graphical approach, because the graphical approach requires human intervention, but incremental search does not require that, and that's why incremental search is at least better than the graphical approach. And as we already said, graphical approach is not suitable for computer implementation, but it is fast. So let's find out a graphical resemblance of what we mean by the limitations of incremental search. Look at this graph. There are some points where the intersection points are very much closely spaced. These roots are very much closely spaced. As a result, if we set a incremental step very large, and it might be larger than the space between these two roots, and hence in those cases we might miss the root location, and that's why incremental search has some limitations. For these cases, incremental search step size should be very much smaller, at least smaller than the distance between these two roots. So we have to be careful about implementing the incremental search and the step size. So what we learned in this lesson, we learned about incremental search procedure. We learned how incremental search can be used to initially guess our upper and lower boundary points. And these incremental search procedure can be used for both bracketing methods and open methods. So that's what we learned in this lesson mainly. We also know the difference between the graphical approach and the incremental search approach, and their advantages and disadvantages. We also seen some of the limitations of incremental search procedure. We have seen that if we set the incremental step size very much large, then we would miss out some of the rules. Also, if we set the incremental step size to be very small, it would cost us much of the computational resources. So we have to make some trade-offs between those. So please try out the MATLAB code of incremental search that I have attached with this lesson. Although this is not mandatory to use incremental search for our for these course, but if you learn about implementing this method, it will be very much helpful for the practical problems that we are going to encounter in our engineering life. So please try out the MATLAB code. And our lessons of bracketing methods, although the bracketing methods were ended in the last lesson, but we have covered an extra lesson of implementing search in this lesson. So there is no bracketing methods further that we are going to discuss. From the next lessons, we are going to learn open methods, although I promised you about starting open methods from this lesson, but now I thought we should have covered the incremental search procedure first, which can be used for both bracketing methods and open methods. So from the next lesson, we are going to start open methods. So till then, thank you so much.